Hey there, everybody. Let's see if I can try to help you figure out your Atwood's machine lab that we're going to do today. Basically, our job here is to show that the acceleration that we calculate from Newton's third law, when we have two objects connected, actually matches what the measured acceleration is. So the picture that we have on our lab handout matches the equipment that kind of sort of looks like this. You have a cart, mass MC, and then you're going to pass a string from the cart over a hanger, over a pulley to a hanger, and then you can attach whatever mass you want to that hanger. We're just going to call this MH, or mass hanger. We're going to assume for right now that the track is frictionless, and so we can figure out the acceleration using Newton's third law. That's what we're going to write down here for predicted acceleration. We actually want to measure what the acceleration is. And to help us do that, we've got a couple of new tools that we're going to use. So first, let's kind of go through a little bit of the theory. In order to measure the acceleration, we're just going to measure a change in velocity over a change in time. And of course, a change in velocity we could write as v final minus v initial over delta t, something like that. And because we're going to let the cart start from rest, we can make this be 0. So all that we really have to do is figure out what the final velocity of the cart is and how long it takes to get there. So in order to measure how long it takes to reach that final velocity, we're just going to use our good old stopwatch timer on our phone. So stopwatch timer is going to give you this time right there. The next thing that we need to do is figure out the final velocity of the cart. We know that we can measure velocity by using change in position over change in time, just like we started learning on the second day of class. So we need a way to measure a very, very small amount of time and a very, very small displacement for the cart when it gets close to the end of the track. And the tool that we're going to use to do that is referred to as a Photogate. So what this Photogate thing is it's basically just two arms that go over the track, and there's this tiny beam of light that goes from one end to the other. And what happens is when that beam of light is blocked by something, this light will come on, and we'll connect it via a cord to this box right here. This box will time how long the beam of light is blocked for. So first of all, make sure that that box is plugged in. It needs electricity. There should be a switch on it somewhere. Just turn it on. And then in order to make it go, make sure that you press this A button until this light right here is on, matching the jack that the cord is plugged into. And then you may have to push this button until you get interval to light up. Then, whenever something blocks the Photogate, we'll see that light come on, and then this box will time how long that thing was blocked for. So, as our cart goes down the track, the little tab that sticks out will go through the beam of the Photogate, blocking it, and we'll learn how long it was blocked for. So we'll need two pieces of information from this. We'll need this time, and then we'll need this width, because this is the thing that actually blocks the Photogate. So take a ruler and measure this time right here, and then we can use that to figure out the final velocity of our cart. So the delta x part is going to come from the tab on the cart. The delta t is the Photogate time. that'll tell you what the final velocity of your cart is. Just divide the width of that tab on the cart by the time you see on the Photogate, and then that's what we can substitute in up here for the final velocity. Real quick, just make sure that you get this width to be in meters. So it should be like a really, really small number because that tab is pretty narrow. So the other thing that you need to do as the cart is moving down the track is time how long it takes to go from start till it passes the Photogate using your stopwatch timer. So you're going to have two times. You're going to have this time on your stopwatch. You're going to have this time from the Photogate. Just make sure you know that the time on the stopwatch is the time in black over there. The time on the Photogates is the time in blue for finding the velocity. So you're going to have to do two times. So it's going to be your job to figure out what mass you should put here and what mass you put on the hanger in order to get an acceleration that's small enough that you can actually measure the time it takes to go from the end of the track over here to the Photogate using a stopwatch. So you're going to have to do a little bit of trial and error in order to figure out what works best, then actually perform it and measure the acceleration. Then compare it to your acceleration that you calculated using Newton's second law. Hope this is helpful. If not, let me know. Ta-ta.